This question is asking about the remaining parts of a triangle. So what are those parts? In this particular case, when they say remaining parts of a triangle, they mean the angles and sides that aren't given. Notice that we're given 3 parts. We're given an angle and 2 sides. That means we need to find 2 angles and a single side. Let's draw a picture to contextualize all this. So we have a side, and an angle. So we'll call this A. We'll call this lowercase a. And we'll call this B. And the reason I organize it like this is because angle A is opposite to side A. Angle B is opposite to side B. That means we have a capital B right here and a capital C right here. My capital C's and lowercase c's look kind of similar. All right. Now, we know this side, and the angle. Now, this can create some ambiguous cases sometimes whenever we have side angle. It's possible that we turn up with 2 triangles. As an example, just a visual one, let's say we know this angle right here. We know this theta. We know this side, and we know this side. That means these lengths can't change and this angle can't change. Well, as you can see, we can create a triangle like so, but we can also create a triangle like that. Notice that these sides are, well, attempting to be about the same angle. So these ambiguous cases can happen anytime the side opposite to the farthest side from the angle, the side opposite to the angle given, is smaller than the side adjacent to the angle given. So in other words, in our case, if A is less than B, then we have an ambiguous case. Now, we're in luck because A is actually greater than B, so there's only one case it could possibly be, which we'll find out now. So we have, with that ambiguity out of the way, let's actually try and find these measurements. I notice again that we have a side and an opposite angle, A and uppercase A, right? That means we can use law of sines. So I want to find, for instance, B. I want to find capital B, our next angle. So that means sine of B over lowercase b is equal to sine of A over lowercase a. And we can fill in some blanks here. That is sine of B, that's the one we're trying to find out, so we can't fill in that one, but we can fill in 20 down here, sine of 18.7 over 24, and then that tells us that sine of B is equal to 20 over 24 times sine of 18.7, just shuffling some terms around, gotta multiply by the 20. I did shuffle around the fraction as well. It should be the same thing, just an aesthetic choice. So when I plug this into a calculator, I get that it's equal to 0.2672. Now notice that I did not find B. What I found was sine of B. So what we need to do then is take a sine inverse. And this is where you definitely have to make sure, well in both cases you have to make sure that your calculator is in degrees, but the degrees I get are 15.5. So we have our first value, which is that B is equal to 15.5. And that is degrees. Now we can actually find C really easily now. When you know 2 angles of a triangle, you can find the third simply by knowing the fact that 180 is equal to the sum of the angles. In other words, A plus B plus C, which is of course 18.7 plus 15.5 in our case, plus C. All right, we can find C just by subtracting then. So 180 minus 18.7 minus 15.5, I get as 145.8. All right, so that's our uppercase C is 145.8 degrees. All right, last measurement is our lowercase c, and that's the opposite side. And there's a few ways you could do this. We actually know lowercase b and lowercase a now, and the angle between them c. And that means we could use law of cosines to find, or uppercase c. That means we could find, use law of cosines to find lowercase c. I'll use law of sines. I find that a little bit easier sometimes, but it's really just a personal preference. So we know that c over sine of c is equal to a over sine of a. Now you may be wondering when I'm setting this up, why is it that the side goes on top in this fraction, in this equation, but the sine goes on top over here? Like the side and then the sine, that's weird, right? Well, the good news is that you can actually write it either way, as long as the entire equation follows that pattern. So here, both signs were on top. Here, both of the signs are on bottom, and the sides are on top. A little thing to note, I like to put whatever I'm trying to find on the top of the fraction. That way all I have to do is multiply. Otherwise it becomes a little more complicated. So I then multiply by sine of c in order to get sine of c. So sine of 145.8 divided by sine of a. So sine of 18.7 times a, which we know as, is it 24? Alright, and when I plug that into a calculator, I get something like 42.08. And those units of measurement aren't really given to us, so it's just 42.08, and that is C. Since we found all three of the missing sides, all three of the missing parts, we are finished.